Hello, everyone. We're going to get started with another day of fun physics. To get started, we have a question of the day. Um, in this question here, I have a graph. I have a position versus time graph. And in this position versus time graph, there are four sections, as you can tell, from 0 to 1, 1 to 3, 3 to about 4.5, and then 4.5 to about 6. And our goal here is to figure out what these velocities are at these four particular points in time. Points in time that we're looking for is at t is at half a second, 2 seconds, 4 seconds, and at 5 seconds. So there are four velocities that we want to find in order as listed below. You have four answer choices to figure out. So let us try to figure this out. As a hint, I will give you a few hints. First off, this is a position versus time graph, not a velocity versus time graph. Very important. Another hint I will give you is that velocity is the change in your position over the change in your time. So you'll want to think about how much my position is changing per second during that time. Hopefully those two hints will help you figure this out. So we will take about 4 or 5 minutes to try to figure this out. I have a poll for you to answer that you can just answer. We have 5 answers so far. We have 21 people. What's our goal today? We hit an A last time. I was very happy about that. But we got to, well, I think in general, I'm pretty happy if we shoot for Bs. So let's shoot for a B today in terms of participation. We have a 5 out of 21, which I think means we need to get about 16 or 17 responses in total. So that means we need about 11 or 12 more. Did I hold on? Uh-oh. That is so that's an issue. Hold on. Hold on. What? This is hold on. I realized that okay, so yeah, I didn't understand. Hold on. It was okay. This is the graph that you're looking at. I don't know what was going on. It was working like a second ago, and then it just like stopped working. I don't even know if any of you saw the graph. This is the graph that you should have been looking at in a perfect world. Unfortunately, sometimes people are not as smart as or capable as they should be, and that is what I am today. So. Okay, so let's take a few more minutes because I realized that my incompetence has unfortunately been a. Can you put the poll back up? Is the poll not up?
if you already answered, like you can't see it anymore. And
Okay,
I
let
thought we
me.
were just like having a little guessing game because I didn't see the graph. All right, thank you.
Okay, I appreciate that. No, 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 no. Yeah, okay, okay. The poll is back up. The graph is up. You can figure it out now. I okay. Also in the future, if I am being clueless, just let me know. You can just say, "Hey, Mr. Pooh, you're being useless," and then I'll be like, "Okay." So that helps. So feel free to let me know if I just like mess something up horribly. So yeah, so it was working, and then I guess it didn't. So okay, so please forgive me for that. That was my fault. I was wondering why I was because we did so well last time. I was wondering why we didn't get that many responses, and it's because you couldn't actually see the problem. So now you can see the problem. As you can tell, there are 4 sections in here. You have between 0 to 1, between 1 to 3, between 3 to 4.5, and between 4.5 to 6. Our goal is to figure out the 4 different velocities at 0.5 seconds, at 2 seconds, at 4 seconds, and at 5 seconds. Our goal is to figure out the velocities at these different points. In order, I have 4 different answer choices for you to pick. 4 different answer choices for you to pick. Yeah. One hint I will give you, one hint, is that this is a position versus time graph, not a velocity versus time graph. The reason why this is important is because in order to find the velocity, we should remember that velocity is the change in our position over the change in our time. So that's something you should take into consideration as we figure this out. We are currently sitting at a 45% response rate. That is pretty solid, actually, considering the fiasco we had about 3 or 4 minutes ago. Our goal today is let's shoot for a B. I'm very happy if we get a B. We got an A last time, so like it's I know it's a little premature of me to expect great things, but I'd be happy if we got an A again. We're sitting at 63%. That means 14 people have responded. We got 15. We need about 3 more in order to hit our goal of 80%. I'll be very happy if we can get 3 more responses. We'll take another minute or 2 for you to figure this out. One thing I want you to remember again, this is a position versus time graph, not a velocity versus time graph. Brett, 16 out of 22. I believe we need 2 more. 2 more people. Can we get 2 more people? I think we can. Oh, wow. We hit our goal today. We are sitting at a 81%. I'm very happy with that. And I will go over how to do this in a second. Oh, yeah, the camera's off. Oh. God, Mr. Hu, what's up with you? I don't know. Good question. There we go. It works. Okay, cool. So let's talk about this problem real quick. So I'm going to go through this as detailed as I can. I would recommend you pay attention and or take notes because your assignment today will look very similar to this, if not almost identical. So that is something you should consider. So I would recommend you pay attention to the best of your ability. So there are 4 sections of this graph. I'm going to label each section here. This is 1 section, 3 sections, 4 sections here. What I call sections are intervals in time. Within each section, the slope is the same. And what do you mean by the slope is the same? Well, it means that you're going up or down or sideways at the same rate. So one thing we should consider is that our velocity is our displacement. Our displacement means our change in position over our change in time. In other words, our velocity is the slope of this graph. So if we want to figure out the velocity at any given point in time, we can do this by figuring out the slope at that particular point. So I gave you 4 points in time that we're looking for. Each one of these points corresponds to a different section of the graph, which means that as long as we can find the velocity of this particular section, of any particular section, we will know the velocity of any single point in that section because the velocity is the same there. Why is the velocity the same? Because the slope is the same. And if the slope is not changing, it means you're traveling at the same velocity the whole time. So how do we do this? So first off, let's figure out the velocity of section 1. So how do we figure out the velocity? Well, in this particular case here, we're looking at we're going to find the slope. And the slope, if you don't remember, is our rise over run. So it's how far do we go up? How much is our position change? How much is our time change? Well, in this case, our position does not change at all. And the amount of time it takes 1 second. So 0 over 1. So our velocity for this section is 0 meters per second, which means that for any time that is between 0 and 1, our velocity is just going to be 0. So in this particular problem, I asked for your velocity at time is equal to 0.5 seconds. Anywhere between 0 and 1 second, it's just going to be the same velocity. It's going to be 0. Let's talk a little bit about section 2. No, let's go to section 3 first. Section 3 is going to look almost similar, well, very similar, if not identical to section 1. So section 3, again, there's no rise because our position starts at 60 and it ends at 60. So there is no change in position at all, which means our rise is 0. That means the top is 0. When it's a run, we start at 3 seconds and we end at about 4.5 seconds. So in other words, the amount of time we spent at this particular segment is 1.5 seconds. So our rise over run is 0 over 1.5, which is 0 meters per second. And this applies for any time that is between 3 seconds and 4.5 seconds. Okay, let's talk about section 2 now. This is when things get a little bit trickier. And another thing you might notice is that anytime in a position versus time graph, right? If our position is not changing, in other words, if our position is a horizontal line, our velocity is also going to be 0. So that's something you should definitely consider. Let's take a look at section 2. So section 2 here is going to be a little bit trickier. We've got to think about how much is our position changing. Well, our position, we start at 20 and we end at 60. So our rise is 40. I'm going to think about how much time does this occur. Well, we start at 1 second and we end at 3 seconds. So it takes 2 seconds to do this part. It does not take 3 seconds. That's another common misconception is you might be like, okay, I traveled 60 meters in 3 seconds. But that is not correct because our velocity in this section is different than our velocity here. So we just don't want to use section 1. We only want to focus on the section where this time occurs. So 40 over 2 is just 20 meters per second. And then this applies for any time between 1 second. No, 2 seconds. 1 second. 1 second. So this occurs for any time between 1 and 3. Yeah. Okay. Last but not least, let's go to section 4. So section 4, we start our position. We start at 60 and we end at 20, which means our position changed. Our displacement was negative 40, not positive 40, negative 40. We know this because we're going backwards. Our position is decreasing. Very important, very, very, very important. Being able to recognize that as you're going backwards, your position is decreasing by 40. And this occurs over 1.5 seconds because we started going backwards at 4.5 and we ended at 6 seconds. So this took 1.5 seconds, which means that our average velocity here, was 26.6 meters per second. This could occur for any time between 4.5 and 6 seconds. So any velocity between 4.5 and 6 seconds. I think I asked for your velocity at 5 seconds, but any velocity between 4.5 and 6 seconds is just going to be 26.6 because once again, your slope here is the same, and if your slope is the same, it means your velocity is the same. Okay, let's talk a little bit about misconceptions. Misconceptions. Probably the most common misconception is reading this position versus time gap, reading it as a velocity versus time gap. So it's very easy to look at this and be like, okay, for the first second, we're going 20 meters per second. For the second second, we're going, 40. The third one, we're going 60. Right? But if we actually look at this, our position is not changing for the first second. So our actual velocity is 0. So we got to look at how much our position is changing per second in order to identify the velocity. So we actually do have to calculate the velocity a little bit. Another one is using times and positions and stuff from different intervals or mixing stuff together. So for example, if I'm trying to figure out my velocity for the fourth interval, it's easy for me to start to use the third interval or use the second interval or use the whole thing. We only want to focus on the intervals where your velocity is the same, right? Because if we use any other intervals, it's going to mess up our calculations, and we don't actually want to do that. Another thing you want to consider is that anytime we're finding the velocities for these particular sections, right? In other words, our current velocity, how fast we're moving currently. This is different than the average velocity for the whole journey. Average velocity for the whole journey is we're going to look at the overall displacement and the overall time, and that is different than your current velocity. So another distinction we want to make in this particular problem, I did not ask you to find your average velocity, but you will want to figure out your average velocity in your assignment today. Last but not least, let's talk a little bit about how to figure out your average speed. So in order to figure out your average speed, our average speed is basically just how fast are we physically moving. We do not care about what direction we're going. We only care about how fast we're physically moving. So for the first example, right, we're not moving, our velocity is 0, so our speed is just going to be 0. For the second one, our velocity is once again 0, so our speed is going to be 0. The second one, second 3. For the second 2, our velocity is 20 meters per second. How fast are we physically moving? Well, we are physically moving at 20 meters per second, so our speed is also going to be 20. The last one, our velocity is negative 26.6 meters per second, which means that we're moving 26.6 meters per second in the negative direction, which means that we're physically traveling at 26.6, positive 26.6, which means our speed is just positive 26.6 instead of negative. Notice how I didn't really do any sort of calculations here. That should hopefully help you figure things out very quickly, very smoothly, without doing too much work. So I am hoping that that was very helpful and that you were able to use this in our assignment today. You will find that it's going to be very similar to this, and I'm hoping that that will be very sufficient and adequate for you. Okay. So what are we going to do today? Hold on. So we are going to try to work on Codenames velocity. We'll try to get as much done as we can, if not completely finished. Due date for this, I said, is next Monday for us. So we will only have today to work on it. On Thursday, Friday, we will be starting a new final sort of topic among velocity and speed. So try to get as much done as you can today. And yeah. And then for your asynchronous assignment tomorrow, you should be doing the Healthy Kids survey. I'm supposed to remind you to do that. Because of this, we will not have any asynchronous assignment. I made a mistake with my earlier classes, but we will not have an asynchronous assignment. So you do not have to do something for us. You have to do the Healthy Kids survey, but you will have an assignment to do that we're working on today. And you'll be working on it for the rest of the week on your own outside of class today. So that is for that. What I'm going to do is I'm going to send you off in your breakout rooms so you can work on your stuff. If you are done with everything, if you're done with it, you should let me know and either ask for help stuff, or you can let me know right now, and I will tell you what we're doing next. Other than that, I'm going to send you off. I've decided to make names for the breakout rooms. I spent a lot of time on them, way too much time on them. So I think they're clever, but they may not actually be clever. So we'll see. Okay, so breakout rooms are open, so you should be able to do that. Okay, so we are out of time here. It's 1:10, so I'm gonna just wrap up here. Hopefully you were all able to make some good progress on it, get close to finishing. If not, completely finish it. That is your only assignment, and that'll be due Sunday, Monday. So Monday for us. We won't have any more class time to work on it because we will start the last sort of topic within Velocity. That will last sort of part. So we'll start doing that on Thursday, Friday. Again, your asynchronous assignment for tomorrow is your student health survey that's not mine, something which whatever the schools or whatever. So you have to do that. But that participation is not whatever. I don't know how that works. Other than that, office hours are daily 2:40, 3:40, and then I will see you all on Friday. Farewell. Bye-bye. Have a good one.
Thank you.
Bye-bye.
you.
Farewell.
Thank you.